Hi everyone, I'm back. This is Check Your Understanding number 2 on page 24. This is still about turning an entire radical as a mixed radical. So let's review. What is an entire radical again? Well, it is a radical wherein there is no number in front of the radical. A mixed radical is when there is a number in front of the radical. Okay. This is an entire radical because there is no number in front of the radical. So what is the strategy that we did earlier? So in questions like this, since it's a square root, you want to be able to factor the radicand, which is the number inside, into two numbers such that one of them would have a square root. All right. 63 would be what? It can be 21 times 3. Or some of you would be like, well, 9 times 7 is better. Well, of course, I just want you to understand that if you are unable to see 9 times 7 right away, it's still okay, right? So let's say it was root of 21 times 3 that you started with. You would probably have seen that, wait a minute, root of 21 does not have a square root, and neither does 3. But if you see this as 7 times 3 for the 21 times 3, wait a minute. When you have two threes, that would have a square root, which is a 3, isn't it? Therefore, you were able to find 3 root of 7. Now, if you're thinking, where did this number 3 come from? Well, that is the result of getting the square root of these two threes, right? Another way to look at it is this, or, oops, let's put it bottom, or another solution is this. Root of 63 is equal to the root of 9 times 7. And here, right away, you can see that, oh, wait a minute. The multiplication property of radicals tell me that I can split it up into two parts. And I have 3 root of 7 as an answer. And if you take a look at the original answer we had, these two are the same. Okay, all right. Next, cube root of negative 80. What would that be? So let's try to do, or let's try to factor 80 into two numbers such that one of them would have a cube root. Now, sometimes when in cases like this, since there are so many numbers to think about, really your facility with the numbers is what's important. That's why I strongly encourage you to really, well, for lack of a better term, memorize the times table, memorize your perfect squares and perfect cubes. Because for 80, for example, I don't know how much time you will take to be able to figure out what numbers to use. Like for 80, it could be 2 times 40, right? It could be 4 times 20. It could be 8 times 10. It could be 16 times 5, all of which would actually work, all right? But then if you ask me with those sets of numbers, this is what I'm going to choose. Why is that? Because 8 has a cube root, all right? So let's take a look. Let's see at let's see what I mean by that, all right? So I will turn negative cube root of 80 into negative cube root of, sorry, into negative cube root of 8 times 10. The multiplication property of radicals tell me I can split this up into two radicals. And this is what I have. Now remember, that negative sign that I'm using only has to appear one time, okay? Because the moment I put a negative sign here also, this negative times that negative becomes a positive. So that changes things now. There's only one negative here. And look, what is the cube root of 8? That's negative 2. And I have an answer right away. For those of you who would have tried the other pairs of numbers, you would still end up with the same answer, but it would take more time. Okay. You may ask me in class to do it for you if you like. What about fourth root of 243? 243, if you're good with your times tables, again, you would have seen it right away. Well, for some of you, you would realize that, well, let's try to divide this by 3, all right? Uh, and this is what you have. If I divide 243 by 3, I would have fourth root of 81 times 3, which is sort of nice because 81 has a fourth root, which is 3, right? The fourth root of 81, which is 3, gives you this one. Okay, there's your answer right away. Okay. Now, I don't know how many of you would have noticed this right at the beginning. The question was, okay, I'm just putting it well, another way, sort of. The fourth root of 243. If you're good with your times table, oops, you probably would have seen, and you or your with your exponents, you know that 243 is 3 to the 5th, right? 3 times 3 is 9, times 3, 27, times 3, 81, times 3, 243. Now, if you're thinking, so what's the point? Well, you can split it up into this one right away, which is what I do. Or you don't need the one on top. Okay. All right. I'm doing an example in the homework section. Sort of a bonus question for you. Root of 99. Turn this entire radical as a mixed radical, meaning there's no number in front. See if you can simplify this into something where in the another radical wherein there's a number outside. And this is pretty simple because 99 is a nice number to work with. The only two numbers that you can use as factors would be 9 and 11. And the idea is see if you can get a factor which already has a square root. And multiplication of radicals tell you to split them up into 2 parts. Some kids would skip this part, and that's okay. However, I do want to see this part, okay, in your solution. Okay. Root of 9 is 3, and there is your square root of 11, and there's your answer. Okay. Now, guys, I strongly encourage you to look at number 7 in page 27 and do the questions there. I don't remember which letters I assigned, but if I were you, do as many as you need to be able to make sure that you understand the concept of turning an entire radical as a mixed radical before you go to the third check your understanding, because the third one will be the reverse. So please make sure you understand this first before you work on how to do the reverse. Okay. That's it for me. I'll see you again in a bit.